Chapter 7 is about multiplying exponents, and I'm going to start out giving you the basics of multiplying exponents. And what an exponent is a number times itself, however many times the exponent is. In other words, this is 3 to the third, so this is 3 times 3 times 3, which is 3 times 3 is 9 times 3 is 27. Well, n is a variable. We don't know what n is, so it's just n times n times n. I'm just expanding it. And then if I condense it again, it's n to the third. N to the third is considered to be the most simplified version. Obviously, it's simpler. Let me fix this. Oh. Multiplying exponents varies. It can be very simple, and then it can become more complex, just like anything in math. So we've already established that x squared is x times itself. X times itself. And x to the fourth is x times x times x times x. In other words, x times itself 4 times. How many x's total do we have being multiplied by itself? X times x times x times x times x times x. We've got 6 x's, so it's x to the 6. Hence, when you multiply exponents, you just add them. 2 plus 4, 6. X to the 6. Please do not confuse this with 4x. 4x means x plus x plus x plus x. What do we get if we add 4 x's? Well, we get 4x. So when you add the x's, you get 4x. But when you multiply the x's, that's when the exponents come into play. Actually, I want to start with an easier problem. So let's look at this problem. And we've got 3 n to the third times 4 n to the fifth. Just multiply the coefficients. Remember, the coefficients are the numbers outside the variable. So 3 times 4, we've got 12. And like I said before, when you multiply exponents, you just add them. So we've got n to the 8th, because 3 plus 5 is 8. Here's another rather easy one, relatively easy one. Remember, there's an invisible 1 here. So negative 2 times 1 is negative 2. And now when you multiply exponents, you just add them. So 6 plus 7 is, we've got p to the 13th. Here's one that a student wrote for me because, as you know, my handwriting is a little bit challenged, if you will. So we've got negative 3 times 2. We're going to multiply the coefficients first. So negative 3 times 2, we've got negative 6. J to the second times j to the, and there's an imaginary 1 here. So 2 plus 1 is 3. So we've got j to the third. And then k, 4 plus 6 is 10. So we've got k, I'm going to move this 3 over, 1 second. J to the third. And then k to the fourth times k to the 6 is k to the 10. Let's take it up a notch. We've got an invisible 1 here. Negative 7 times negative 5 times positive 1. Negative times a negative is a positive, so we've got positive 35. So 35. M to the 1. No m here, we don't have to worry about it. M to the 1 times, that's a 1. M to the 1 times m to the 3 is m to the 4. And n to the 1 times n to the 5 times n to the 6. 1 plus 5 plus 6, we've got n to the 12. And it's solved. We just solved that one. Now we're going to look at a power raised by a power. That's the way it's normally termed. As you know, a power and an exponent is the same thing. So I'm going to call it a power raised by a power. N squared raised to the third power. Well, that's n squared times itself with this third power. It's saying multiply n squared times itself 3 times. So let's expand it. We've got n squared times n squared times n squared. Okay, so we just handled that, the power being raised. Let's expand it all the way. N times n times n. This is the second n. Now we're on the third n. We just expanded it. How many n's do we have? We have 6 n's. N to the 6th. We have 6 n's. So how is power 2 and 3 related? You've got it. 2 times 3 is 6. So when you have a power raised by a power, you just multiply them. So if you have this, you add them. You get n to the 5th. Okay? But when you multiply them, when you have a power raised by a power, then you multiply them and you wind up with n to the 6th. You see the distinction? Let's look at this problem. We've got negative 3ab to the third raised to the fourth power. Let's go ahead and solve it. So we've got negative 3 times negative 3 times negative 3 times negative 3. Negative 3 times negative 3 is positive 9, times negative 3 is negative 27, times negative 3 is positive 81. So we just solve that part. A to the 1, what's 1 times 4? Well, 4. We've got a to the 4. B to the third, raised to the fourth power. What's 3 times 4? 12. We've got b to the 12. We just solved that one. Now we've got x squared, y to the fourth, raised to the fifth power. Like I said, when you have a power raised by a power, you just multiply. So we're just going to multiply them. X squared, raised to the fifth power, is x to the 10, y to the 20. We just solved it. Now let's look at this scary one. It appears to be scary, but it's not, and I wrote it in light blue to make it a little bit less intimidating, kind of a more cheerful color than black. So let's just solve it and just take it piece by piece. There's an imaginary 1 here with the 2. So 1 times 3 is 3, so what we have is 2 to the third power, and let's go ahead and solve that. 2 times 2 times 2, 8. X to the third. Well, remember, a power raised by a power, you multiply. 3 times 3 is 9. So x to the 9. Okay, y squared. We've got y squared raised to the third power. 2 times 3 is 6. Y to the 6. Z squared raised by the third power. Same thing. Z to the 6. And now we're going to multiply that by, we can use the dot, or we can use parentheses. I'll stick with parentheses. We're going to multiply that by this next one. And remember, we're following the order of operations. So we're going to do the exponents first. Exponents always come before multiplication. So x to the second power. X to the 2 times 4 is 8, so we've got x to the 8th power. Z to the 4th power. 4 times 4 is 16, so we've got z to the 16. I'm going to go ahead and put parentheses around there. Now we're just going to multiply. We've got the invisible 1 here. 8 times 1 is 8. We'll talk about imaginary numbers at the end of the year. X to the 9 times x to the 8. This is not a power raised by a power. We're just multiplying exponents. Remember, when you multiply exponents, you just add them. We have x being multiplied by itself 17 times. So that's x to the 17. Y to the 6 times, well, there's no y here, so let's just write y to the 6. Z to the 6 times z to the 16. Well, 16 plus 6 is 22. So we've got z to the 22. And there we have it, our solution. 8x to the 17, y to the 6, z to the 22.